Subash, you want to do a mic check to see if that works out well and everything?
Test.
Seems to be it. Anything else, Subash? Anything else? Do you want any water? Anything like that?
No, that's okay. I just want to make sure that the stream is working.
Subash,
Alright, cool.
the one thing I'm way behind is sponsor. He knows all the money guys. And he's pouring now a little bit. He's giving us a little bit.
Hey guys, we're going to get started. You can come and take a seat. So before we start today, just a few announcements. September 10th, we are having a meetup with Ron Bodkin. I think I mentioned this last week. Ron Bodkin, CEO of Think Begin and Analytics, will be coming to do a talk. He'll be here at Factual itself. I'm going to post the meetup sometime later this week. We also have another talk scheduled for September 25th. It's going to be a Hadoop environments talk versus private virtual clouds. This is going to be done by a stealth startup out of the Bay Area called Blue Data. I've been talking to them for quite some time and they have a very interesting product. But it's going to be very technical and we're going to discuss how Hadoop dev environments versus private virtual cloud setup and what makes the best use of resources for companies who are trying to get into Hadoop. Also, I mentioned that the CAD was on a Spark users group. So I got confirmations from 3 of the big database vendors, I would say Hadoop vendors. So Cloudera, Mapr, and DataStax have signed on. Hortonworks also is almost out there. Sam, who's from Hortonworks, he's helping me out. So hopefully we should get that on track. So once I get the information as well as the location, I'll post it on the Spark users group. It's going to sell out really fast. So as soon as I post it, you guys got to sign up and register for that. Last but not least, October 7th, I think I have another talk scheduled, as well as October 22nd. I'll post more information about that as the weeks go along. Hadoop World is October 15th to 17th. So if you want free tickets, I posted that last week. Put a business card in that box. We're going to be doing a selection sometime this week and we'll email out the winner. Obviously, you need to get flight and hotel tickets, but at least it takes away some of your costs, $900. That's a lot of money. So without further ado, I'm going to start now on the HBase topic. How many of you are familiar with HBase? Know something about it? Everyone is familiar with HBase, so why do you even do the intro? Anyways, I'll just go over HBase. I won't tell too much about it, but I'll just discuss what it is and get into a lot of the use cases as well as some advanced topics in HBase. So with that, let's get started. So what is HBase? It's an open source distributed sorted map model after Google's Bigtable. So Google Bigtable paper came out in 2004, and HBase was modeled after that. It pretty much follows a sorted key map solution that's built on top of Hadoop. It's one of the only NoSQL solutions out there that currently uses Hadoop. I think Accumulo is another one that uses Hadoop, but Accumulo pretty much is just being used by the NSA and enterprise companies that need security at that kind of level. It's a top level Apache product. It has been for quite some time. How many of you are familiar with the CAP theorem or Bros theorem? So CAP theorem or Bros theorem was developed by this guy called Bro, and basically the CAP theorem states or has these 3 particular notions, which is consistency, availability, and partition tolerance. In consistency, all nodes see the same data at the same time. Availability, I guarantee that every request receives a response, whether it is successful or not. And partition tolerance, system continues to operate despite arbitrary message loss or failure of part of the system. But according to the theorem, what it states is on a distributed scalable system, we only have 2 of the 3, not all 3. So just to give you an idea of how it looks like, this is what it would look like in a NoSQL guide or visual NoSQL guide. So if you have the consistency, availability, and partition tolerance, different NoSQL solutions fall in different parts. So for example, availability and partition tolerance is something that's done by Dynamo, Voldemort, Tokyo Cabinet, Cassandra, SuperDB, CouchDB, React. HBase solves in the consistency and partition tolerance. So Bigtable, Hypertable, HBase, Mongo, Terrastore, Berkeley, and all these nicely fit into that picture. And most of your RDBMSs fall in the consistency and availability. So MySQL, Postgres, Vertica, Astra Data, so on and so forth. So pretty much this one tells you, where exactly you're looking for, what do you actually want. Consistency is something that a lot of people demand. Hey, I want to make sure that my data is the same across all of my nodes in the cluster. Availability just says that when I ask for something, I want to get it right then and there. I want the answer to be correct. I want it to have a different answer than what it was. So if I write something now and I read, I want it to have the same thing. I don't want it to have an older version of the answer. Partition tolerance just ensures that you can partition your data across different nodes and it's successfully able to scale as you grow. So HBase falls into the consistency and partition tolerance. Availability is something that it's still not available. It's not completely there, but it's something that it's being worked on. So when people talk about these things, they're obviously talking about 2 of the 3 that are specified out here. So moving forward, what are good use cases for HBase? So typically, you want to do HBase, you have lots of data, hundreds of gigs to petabytes. You have a high throughput, so it's very good for writing thousands of records per second. It's also a scalable cache capacity. When I say scalable cache, what I basically mean is that you can just throw nodes in and it'll keep scaling as you throw the nodes in. And data layout, it excels at key lookup, and there's no penalty for sparse tables. Anyone familiar with the sparse table concept? So a sparse table, if you know, in a regular RDBMS, when we store a null, it actually takes up disk space on disk. Sparse table, the concept is, nulls don't actually take up space on disk. You actually save on that. So if you have a table with lots of nulls, you actually save space, but you don't actually writing null to disk. So column-oriented databases. So HBase, when people talk about HBase, pretty much talking about a column-oriented database. HBase belongs to the family of databases called column-oriented. Column-oriented databases save their data group by columns. In a typical RDBMS, what happens? You have rows of records that you store your data. In a column-oriented database, you actually group them together by columns. So let's, for example, you have a user table or an employee table, and you have employee name, employee ID, and maybe something like start date. And in a regular RDBMS, you just keep adding multiple columns in, and when you want to pull a record out, you just pull the whole record. In column-oriented database, you can actually group them together. So if you have an employee database with employee name, user ID, and let's say start date, you can group them together as one column family, and we'll discuss the concept of column family later. But basically, you can just group them together. Let's say you want to do like department, salary, and things like I don't know what car he drives or something like that. You can also group that together into a separate table. Now, what is the basic philosophy of this? Why would you want to do this? If you think about it, if you put this into an RDBMS, whenever you pull a record, even if you pull out, say, you do a select, say, employee ID or employee name from the table, typically what RDBMS does is actually pulls out the whole record and then pulls out those fields from that table. In a column family database, you can only say, I want to pull out, employee ID, employee name, and just because it belongs to one column family, it does not go and pull the information from the next column. Just can pull information from that one column family and give that information to you. So you're typically saving space on disk I/O. That's one of the big reasons we would look at that. Because whenever you pull data from HBase or from any RDBMS, you actually go into disk. If you think about that, having a spindle disk, especially with disk seek and disk transfer rates, that's a lot of performance penalty on how fast you can access the data. If you have lesser number of columns of data to pull or lesser number of data blocks to pull from, you probably are going to get a better response rate, right? So that's why you would look at something like using HBase versus using a column-oriented database versus a row-oriented database. The difference between the two. So as I mentioned, reasons to store values on per column basis is based on the assumption that specific queries, not all values are needed. Most cases you typically do that. You typically do select. You rarely do select star unless you want all the data. most cases you're always doing select this column plus this column plus this column. So it makes more sense in those cases. So reduce IO, one of the primary reasons for this new layout. As you can see, you're doing lesser number of IO operations compared to when you have to pull the entire record out. Lastly, the main thing I would say over here, the biggest advantage column-oriented databases is the compression or specialized algorithms you can apply. If you think about it, in row-oriented databases, all your fields can have different data types, right? Some could be string, some could be int, some could be float, decimal, so on and so forth. Whenever you apply a compression algorithm, you got to apply an algorithm that works across all of them. So you have to apply something uniform. You can't apply something that's specific to integer, specific to decimal, specific to string. In column-oriented databases, since data is stored in columns, your compression algorithm could actually target it to that particular column. So if you have an integer column, if you have an integer compression algorithm, you have much better compression rates than when you have something that's generic or something that's uniform to all of the records all of the fields in the table. So that's one of the reasons that you would also look at column-oriented databases, because you can apply specific algorithms just to that particular column. Any questions so far?
So the column grouping in families, this has to be decided based on the usage of the application, so that administrator will have to decide how to do that.
Yeah, I mean, typically when you group things into similar column families, you typically know what the grouping is. So if you have an employee table, the easiest way, I mean, at least what I think in my mind, easiest way is to do some kind of normalization. And as long as it's dependent upon the whole table is kind of like can be grouped together in a normalized form, I would say that would be a good way. But I'm just giving you a kind of like a relation between the two. It's not a perfect thing, a perfect way to choose what columns go into column family, but it gives you an idea of how exactly you can put things together. But that doesn't mean that it works all the time, because there's maybe some use cases where you need more columns than what you have. So an employee table, typically employee name, address, ID, those all go together into one table, because they are very less frequently accessed versus something like employee department or kind of work he does or what projects he's working on. Those are things that more frequently access. So those you probably want to have in a separate column family.
Is it possible to have one column belong to multiple families?
Yeah, sure. You can. So here, the thing with HBase is it does not put a specific constraint on you. So you can have, let's say, you have name in an employee table. You can also have name as in a employer table, and they could be part of the same HBase table. So you have one column family for employees, one column family for employers, and both of them can have name. So there's no constraint. You can actually do whatever you want, as long as within the same column family you don't have multiple column names with the same name. Okay, let's move forward. So even though I said HBase belongs to a class of family of databases called a column-oriented database, it doesn't use the entire column-oriented structure. It's not completely column-oriented. So it is not column-oriented in typical RDBMS sense, but utilizes on this column storage format. So the only place you would see the column-oriented storage format or oriented design is when it actually stores data on disk. So majority similarities end there, because although HBase stores data on disk in column-oriented format, it's different from traditional column-oriented databases. So one of the things that they're different in is most column-oriented databases provide real-time analytic access to data. HBase excels at providing key-based access to a specific cell of data sequential range of cells. So that's where its performance or its greatest power lies, when it has to do key-based access to specific cell range of data or sequential range of cells, versus doing the real-time analytic data that goes all over the place. So that doesn't mean that it does not do random reads and writes, but it provides better performance when it does there's a range request versus a single request. So HBase and Hadoop. So what is Hadoop good at? So Hadoop is good at storing data of arbitrary, semi, or even unstructured formats, since it allows you to interpret how the data can be done, how the data can be analyzed at runtime. So as you know, in most cases, if you do high, peg, or even Hadoop, MapReduce. You pretty much just throw the data into HDFS, and based on how you query it or perform your queries, it will actually run the NS. So I was what they call it's a schema on read versus schema on load, right? Because what that means is basically only when it actually reads from the HDFS data, that's only when it performs the operations. Similarly, MapReduce or anything, it's always when you read on the data rather than when you actually load. You can actually load garbage in, but garbage in, garbage out. So you're obviously going to get garbage out as well. But what that means is it does not check to see how the data is stored on disk. It's already done when you actually process the data. So HBase sits on top of Hadoop, and because of this, you can always use the best features of HDFS, such as scalability and data replication, and other things that Hadoop offers. So when would you not use HBase, or when HBase doesn't make sense to do? So when your data access patterns are unknown. So one of the things with HBase is that it's a data-centric model versus a relationship-centric model. What that means is that if you need to know how your data has been accessed on HBase. If you don't know that and you try to put two things in HBase, typically what happens is that you're going to have to rewrite your HBase table at some point. And that means if you have hundreds of terabytes of data, or even even hundreds of gigabytes of data, what's going to happen? It's going to take a long time to regenerate the table with the correct data access pattern. So typically, and the process, especially when you don't know your data access patterns, you sort of test things out. So you probably write a small data table, you try to put data in, you try to figure out how the data is being accessed, try to look at the patterns, and then finally work on creating your actual table. That's typically my way, especially when I come in new to a company and trying to figure out how to create a table that has the right access patterns. I try to create something that's which I think is right, and then I try different things out based on how I see the actual patterns are. And when I do that, I don't try to move all the data in. I just try to move a little bit of the data so that when I know that I have the right access pattern, I can actually convert it to the right format and then move all the data in. So I don't lose a lot of time in converting the data from one table to the other. So it doesn't make sense to bring RD models for HBase because, as I said, it's data-centric versus relationship-centric. Also, if you have small amounts of data, it doesn't make sense. Just put it in RDBMS. So anything, I would say small amounts in gigabytes of data, it's easier to put that in an RDBMS. Also, if you don't have too many random read writes, with a limited random read write, just use HDFS directly. If your data is mostly sequential, it makes sense to just go directly to HDFS. So now I'm going to talk about Facebook. So Facebook is one of the biggest users of HBase. They were there from a very long time. One of the things with Facebook and their version of HBase, they forked off 0.89 of HBase, and ever since then they have pretty much kept on building their own version of HBase. They patch things back now and then, but for most cases, their version of HBase is, I would say, quite different from what, even though one of the things that people have noted is that things which Facebook has done, the HBase community sooner rather than later implements them on their own, even though they don't hear about it from Facebook until much later. So Facebook goes and says, hey, we implement this, and the HBase says, oh, now we also implement that, and we're like, oh, now we both know the. So even though the project diverges, like-minded people think alike, and they implement the same solutions to the same problem. Because at some point, Facebook has already seen the problems and they figure out how to fix them. And at some point, some of the companies implementing HBase will go across the same problems, and then they go back to the community and say, hey, this is the problem you're seeing, we need you to fix it, and then they think about the problems and solutions in the same ways. So the Facebook messaging platform, which many of you use today, was built completely atop HBase. It was chosen because of the high rate throughput and low latency random reads. Other features such as horizontal scalability, strong consistency, and high availability via automatic failover made it a good choice to use HBase. In fact, there was this story, about this story, but it was actually fact. So Facebook actually developed Cassandra back in the day, and when they were looking at what database to use, they actually paired Cassandra, MySQL, and what we call HBase, and they chose HBase. And the main reason was not because of performance, but mainly because HBase started on top of Hadoop, and Facebook already had a huge Hadoop installation, and it kind of made sense that since HBase resides on top of Hadoop, the administration of HBase wouldn't be so bad as compared as having your own Cassandra cluster, which means you need to have a Cassandra admin and so on and so forth. So that's one of the main reasons. It wasn't performance related, it was mainly because of the fact that HBase relied on Hadoop. So what are the things Facebook uses HBase for? In addition to online transaction processing workloads like messages, they also use it for online analytic processing workloads where large data scans are prevalent. They also use it, they moved it to multiple systems. So their internal monitoring system recently launched nearby friends features, search indexing, streaming data analysis, and data scraping for internal data warehouses. So they use it pretty much in a lot of their systems right now, and they're still migrating a lot of things onto HBase. So a lot of things going forward will be moved onto HBase just because of its scalable features and the fact that HBase and Facebook is growing petabytes of data. I think last year they were at 2 or 5 petabytes of data. I mean, they pretty much randomly, they're exponentially growing their data sets. I think I could be wrong, but it probably must be more than 2 or 5 petabytes. It must be hundreds of petabytes right now. Because Google is in exabytes, and Facebook is not that far off either. So we're going to talk about some of the advanced features of Facebook and their fundamentals, and then we'll go and get back into the use cases or which companies are using Facebook. HBase. So seek versus transfer. So one of the fundamental differences between an RDBMS and NoSQL ones is use of B or B plus trees and log structure merge trees, which is the basis of Google's Bigtable paper. In a typical RDBMS, you create your indexes. What it usually does is it creates a B plus tree index tree. So what that means is every time you insert a record into your table, you're pretty much inserting into the B plus tree. The way B plus tree works is you have it writes a bunch of these keys into memory, and the moment you insert something, it goes and inserts another value into that particular range of values. So you actually do it pages through these indexes of keys what you may have, and it adds the keys in. So as your data grows, your index of memory also grows. So when you have to insert, it takes a longer time to do the insert. I don't know if you notice this. So one of the key things, at least when I was doing the MySQL world, whenever we had to do a large bulk load, we typically turned off the indexing feature. We did a large bulk load, and then we turn on the indexing feature because that was way more faster than trying to insert directly in the table where index is turned on. Because it did a lot of checks and took a long time just to figure out. I think it's pretty much the same, but a lot of people actually do that because of the fact that it's much faster. If you think about the reason why it does that is because of the B plus trees. It's actually adding values to these indexes, and as they grow over periods of time, it does grow. It actually creates larger amounts of memory, which means you need to insert random values into random locations, into random points in memory, which takes a longer time to do. And if you have let's say a 20 gigabyte table, and you have RAM of only 4 gigs or 8 gigs, you're probably going to need to page through to insert a specific value in a specific location. That's why it takes a long time to have your index update, especially have large amounts of data. So B plus trees allow for efficient insertion, lookup and relational records identified by keys, represent dynamic multi-level indexes with lower and upper bounds per segment or page. So as I mentioned, it does this by pages. You pages in chunks of data into memory, makes changes to that and pushes back out. Allows a higher fan out compared to binary trees, resulting in lower number of IO operations. Range times also very efficient. But as I mentioned, right, if you have larger amounts of data, B plus trees becomes an impediment rather than an actual improvement. So in LSM trees or log struct merge trees, incoming data is first stored in log file completely sequentially. Once a log has been modified, we say updates are done in an in-memory store. Once enough updates are accrued in memory, it flushes a sorted list of key record pairs of this, creating store files. At this point, all page to log can be deleted since modifications are persisted. So, in simplest way to understand, as data comes in, you write it first to a log file, then you read the log file, put that into memory. As changes come, updates come, you just modify the data that's in memory. And then as time, when the buffer gets full or your threshold has been reached, you flush that out to disk. And every so often, you go back and combine these files and merge them together to make them bigger. So the fundamental difference, disk drives. Too many modifications force costly optimizations. In the LSM trees, you're not actually doing too many modifications. You're actually writing to a log file and then putting that into memory and making the changes to what's available in memory, not on disk. So you're actually not going back and forth to pull in data from disk. More data at random locations causes faster fragmentations. Updates and deletes are done at disk rates rather than disk transfer rates. So in LSM trees, it works at disk transfer rates, scales better to handle large amounts of data, guarantees consistent insert rate, transforms random writes into sequential writes using log files plus memory store. I thought this was one of the very interesting things. By converting these random writes into sequential with in-memory store, you can have change the entire dynamic of how data is actually being, I wouldn't say processed, but actually being available for quick and easy and performant access to the data. By making this possible, when you have petabytes and terabytes of data, you obviously cannot do an index in B+ and expect it to have real fast performance. In this case, because it's doing it in this particular fashion, it's able to do that. Also, reads are independent from writes, so no contention between the two. Make sense?
Just to be clear, which one is this? Is this LSM where it reads independent from writes?
Yes. So, getting back to the basics, so when I talked about LSM, how is this implemented in HBase? And it's pretty much the same. So when data is added to HBase, it's first written to the wall called the write-hide log. It's also called the H log and stored on disk. Once the write is done, it is then written to an in-memory called memstore. Once the memory exceeds a certain threshold, it flushes to disk as an H file. Over time, HBase merges smaller H files into larger ones. This process is called compaction. So this is exactly how it works in LSM trees, and why HBase is able to scale much faster than an RDBMS. So why it's able to write high volume writes. So one of the things I think Flurry or Facebook for that matter, they have writes of about 250,000 writes per second on HBase cluster, which is pretty fast, which is humongous. I mean, that's a lot of writes. I think Facebook is I think 1.3 or 1.4 million, if I'm not mistaken, but it can scale like crazy. It can write really fast. Obviously, you need to do in your closed channel, and Facebook has done a really good job. Again, Facebook forked off and they built their own thing, but it goes to see the show that HBase can scale at really high levels compared to other solutions out there. So how does it look? So your client API is out there. You have a master, HMaster, which controls where the data is actually stored. And the data goes to the write-hide log, as I mentioned. The write-hide log will then write the data to the mem store. Every so often, when the threshold is reached, flushes it out to disk as an H file. And then the H file resides on top of Hadoop in HDFS, and that's where it actually written to. So just a couple of, some terms that you need to understand how HBase uses its or HBase terminology in terms of the server and the access points, as well as what is being used under the HBase servers. So first, typically when you store data in HBase, you store it in regions. So a region is basically a subset of table rows like a partition. A region server is something that serves data for reads and writes, and it's usually a collection of regions. A region server will also reside on one data node. So you can see a one data node will have a collection of regions, which will have a collection of subsets of tables. You have the master, which is responsible for coordinating the slaves, the region servers, and it assigns regions to detect failures of region servers and controls some management functions. Other things that are important is zookeeper. So I'm not sure Also, a lot of you are pretty, if you have used Hadoop, you pretty much use Zookeeper, because Zookeeper is one of the distribution quorum engine that's being used pretty much by a lot of the Hadoop projects as well as other open source projects. It stores global information over the cluster. The other things that you need to know is the root file and the meta file. The root file is a table that lists all the meta tables, and the meta file is a file that consists has a list of all the tables in the regions and the locations. So where this works is when you first make a call to Facebook or the client requests something from HBase, it actually makes a call to Zookeeper, and then Zookeeper returns the location of root. So when the client says, hey, I need access to this data, it will first go to Zookeeper. Zookeeper will say, it'll ask Zookeeper where's the location of root, then it will go to root, then it will ask root where's the location of meta, then it will go to meta, and within meta it will look at all the tables in the region and locations, and then it will go to that particular data node or region server and pull that information out. Now this is done only for the first time, it doesn't do this every time. So just from the first time, it needs to know for the first time where the table of the data is located, it will go through this entire process. And subsequent calls directly goes to that location and pulls that information out. So there is no bottleneck of going through this process and all the time. The only other time it will go back into this process if for some reason the data does not come return or the client fails to respond. At that point, the region server may have been down or something like that. It will go back to Zookeeper and ask them this entire process again and figure out where to go and pull the information out. Actually, sorry, it wouldn't go to the Zookeeper, it will go back to meta and figure out whether, unless meta has changed, then go back to root, unless root has changed, then go back to Zookeeper. Because it already knows the locations of all the other things in its first call to pull all this information out. So the reason I wanted to go over all this is because I want to talk about Facebook's HBase. So HBase is Facebook's new and updated version of HBase. So as I mentioned, when we forked off 0.89, we're currently at 0.98. So obviously it may not be a lot in terms of versioning, but 0.89 came out, I would say 2 years or 2.5 years ago. So they forked off a long time ago on this, and currently at 90. So you can think about how many years of development Facebook has had. So in HBase, when a region server fails, all regions hosted by the region server are moved to the another region server, which is great. So failover happens. The problem happens is, when you're failing over, you have to split and replay your walls. So remember when I mentioned that when data comes in, it's first written to wall, and then it's written to in-memory store, and then flushed every so often to disk. Now, because data when you store data in HDFS is replicated 3 times. So what that means is your H files, even though the region server goes down, you still have 2 more copies of that H file somewhere located. The problem is your wall. Your data, basically what that means is your recent data has come in, it's in the wall, but it has been flushed to disk. So you need to replay your wall so that you can actually go and push that to memory and then flush it to disk. So it's available for persistency and storage on disk at some point. Now, when it fails out on the region server, it means it has to replace this wall, which could take time, and which lengthens the failover and moving over the data. So HBase differs from HBase in this. So instead of having a region, typically one region server would hold one particular region or several or multiple regions, but in HBase, one region is actually hosted by a set of region servers. So it becomes a many-to-many relationship. Previously, one region server had many regions. Now it's one region server and many regions, as well as that same region could belong to many region servers. So when a region server fails, there are standby region servers ready to take over. Why is this important? So standby region servers can be spread across different racks or even data centers, providing availability. Set of region servers serving each region form a quorum. Each quorum has a leader that services read and write requests from the client. HBase uses the RAF consensus protocol to ensure consistency across the quorum. And with a quorum of 2F plus 1, HBase can tolerate up to F failures, which is much better than it was before. Also, if you look at this, Facebook's reliability with HBase was 99.99, and they just moved to HBase to 99.999, which gave them approximately 5 minutes of downtime per year. So for Facebook, they needed even more reliability. So they moved from 2 nines to 3 nines. And now obviously everyone wants to go through 5 nines or 6 nines, and that's what, less than 120 milliseconds of downtime a year, something like that. So Facebook is working towards and going towards that. But right now they moved from 2 nines to 3 nines, which is pretty good. So another user of HBase, and I would say Flurry is the biggest user of Apache HBase. The reason I say Apache is because they actually taking it from trunk versus forking off and building on your own. So Flurry is a mobile analytics monetization advertising company founded in 2005. They were recently acquired by Yahoo for north of 300 million. I think they said 300 million to a billion. For those of you who want to know how much they were bought for. They have 2 data centers with 2 clusters each with bidirectional replication, 1,000 slave nodes per cluster. They are cluster configuration, 32 GB RAM, 4 drives, 1 and 2 terabytes, 1 gigabit Ethernet switches, dual quad-core processors with hyper-threading, so gives you 16 processors. They have approximately 30 tables, 250,000 regions, 430 terabytes after compression. The biggest tables, the 2 biggest tables are approximately 90% of that. So they have 1 byte table with 3 column families, 4 billion records with 1 million cells per row. The other tall table with 1 column family, 1 trillion records and 1 cell per row. So I think thinking is that they're using the secondary table as an index to the primary. That's why HBase has this concept of only single index. So when they want to do a secondary index, or they want to access their data patterns through another way, the second table makes sense. So that's why I think it's doing the 1 column family, 1 trillion records and 1 cell per row. Any questions? So, go ahead.
Going back to that 2 table, there is 1 table and 1 index table, right? Because it's not. Index is for only 1 table.
No, so both the tables have only 1 index. So the row key, when you design HBase tables, you design a row key. So the first table is a white table that has all your data. The second table, so you can only have 1 data access pattern in your first table, right? HBase has only the concept of single indexes. You can't do secondary or tertiary unless you use Phoenix, in which case gives you a secondary index. So my understanding of what I think they're doing is they're using secondary table to create a secondary index into the first table.
Because all the first tables, all keys has to be indexed.
So they could do different patterns in that. So they have billion records, so they could try different variations and store that in the second table, which will index back into the first table. So they can quickly go and say, how is this? I want to access the record in this particular fashion. So where is it stored? And then that will point to location in the original table. So you can just go and pull that information out. This was how it was done for a very long time. Even today, it's done in HBase. The second access patterns. Of course, Phoenix allows for somewhat better use case, or you can actually do that with Phoenix and have a secondary index. So HBase security, one of the big things in HBase 98 was the fact that they allowed for, or they implemented a number of security features. How many of you have heard of Accumulo? So Accumulo is the database developed by NSA. It was also a Bigtable clone. But because it's developed by NSA, there are a bunch of security features which they touted over HBase. Both Accumulo and HBase run on top of Hadoop, but they were touting it in much more secure. And for a given reason too, that they were built by the NSA, so the security features are much more, much more complete, or feature complete. So HBase has implemented a number of security features in 98. So things like cell tags. So now all of your HBase data is actually stored in tags, which can also store metadata and other kinds of things. So the other thing that is stored in there is cell ACLs. So it enables reads, writes, checking of reads, writes, execute, admin, and create. So that's stored as part of the cell tag. We have cell labels to do visibility expression support via the security co-processors. Co-processor is basically the extension to HBase. I won't go too much into detail, but it's kind of like writing comes a Java function, an extensible Java function to do things that HBase doesn't offer by default and so on. But the great thing about co-processors, it makes HBase much more, extensible and things that you want to do. And some of the core process features that they have endpoints and observers. And if you're more interested in that, you can take a look and search for the web for endpoints and core process. There are a lot of articles that talk about it. I won't go into detail about it right now. The other thing that it does is transparent encryption. So data is encrypted on disk. So when data is being written to disk, it's encrypted and decrypted and it's read from disk. Also RBACs, role-based access control. So now HBase does support that using Hadoop group mapping services as well as the ACLs. The Hadoop group mapping service is a security feature which was implemented in Hadoop recently. It's nothing but by default it looks at your Linux user groups and takes that. But if you want, you can actually do your own custom user group. So if you're a user and you want to be part of a user group, only within Hadoop, you can just use the Hadoop group mapping service to do that. So by default, if you don't do that, you just use your default Linux user groups. And it uses that in ACLs to do RBAC. I won't go into what RBAC is, but if you're familiar with security and when people want to access data or touch the data, RBAC is one of the things they look for audit controls and other things like that. Any question? You guys are very smart. You guys know nothing about HBase. Alright, so the next thing I want to talk about is Phoenix. So for a long time, HBase could be accessed only through Java. They are native APIs which are Java based. And then they also had Hive over HBase, which was a SQL layer, but problem with Hive over HBase was all MapReduce. So whenever you wrote any Hive query, it actually converted that to MapReduce and then run it over HBase, which meant that it always took a long time to return the results. But I mean, given that HBase supposed to return results in real time, Hive became a very good feature. Only in certain cases where you have data analysts who want to access the data and didn't worry about the time they should do that. So Phoenix was created by Salesforce, and Phoenix is a SQL layer on top of HBase. It has a query engine, metadata repository, and embedded JDBC driver. It's a top-level Apache project. It's currently only for HBase. It's currently the fastest way to access HBase. Reason being, it supports specific pushdowns, compiles query into native direct HBase calls, no MapReduce, and executes scans in parallel. The other things it integrates very well with Pig, Flow, and Scope. Also, the other way the Phoenix works, as I mentioned, HBase is a data-centric model. So Phoenix maps HBase data-centric model to a relational world, and that's how it implements the SQL layer on top of HBase. So I wanted to show you this query that was run on top of Phoenix on top of HBase, and the same thing is run in string or Hive 0.13. So it will select star from table where k and so on, so on, so. In Phoenix, it came back in 0.04 seconds. In Hive, it took 280 seconds. So you can see the performance, 7,000. It was run on a 110 million row table. So it's a pretty large table that it ran over. And so almost close to an RDBMS return, response rate. So that's how fast it is by using Phoenix.
That's selecting the key field?
Yeah, so Phoenix allows you. So Phoenix, in addition to doing the primary row key in HBase, it gives you a secondary index. So from what I think what they did is using the key directly in this to pull out the value. But if you look at Hive does not give you any indexes. Hive because it's directly HDFS. But Hive 0.13, which is case based, was supposed to make things faster. But given that HBase or Phoenix at top of HBase is much faster because it quickly scans the index and pull that value out. It's able to put the information out much faster than what Hive would have been. Because Hive does not have a concept of index. Every time you do a Hive query, converts it to Java MapReduce and runs it on top of HDFS. Which means you start the JVM, run all the processes, the data against that. Even though performance stays, enhances the performance and shortcuts a lot of the other things out, it still has to do a lot of these processes in place before you can process the data and give it back to you. And it has to process the entire data set, not just chunks of data. In this case, HBase can just directly go down to that and index it directly into that particular location on disk and pull the value out.
Someone had a question. So what you're saying is, in some sense, Hive is going through some analytics that the Phoenix did. But at the end of the day, we want to run analytics on there. So do we have a comparable numbers for doing complete analytics with Phoenix?
So when you say analytics, you probably mean that, okay, you're trying to process some data on top of HDFS that's stored in Hive, right? In this case, even if you don't have a good access pattern, you haven't designed your key for that particular access pattern, you probably get, I wouldn't say exact 0.04 seconds, but you still get very similar rates to the fact that you have a secondary index which you can make use of. If you're looking for something like a tertiary or fourth index which hasn't been created, then obviously you're going to have certain lookups, and you need to design in certain cases. So if you have a pattern that says, that I have this tertiary design, you create a secondary HBase table which can index back into the first one with that specific value. That's how you typically do that in those particular cases. So if you know your index, your data access patterns, you build your tables around it. If you don't have a data access pattern, if you think something, if you watch a video down the line for analytics, for example, like your data analyst comes and says, hey, I need to process the data in this particular method, you can create a secondary table that indexes into the first with that particular data access pattern. Which will give you access to the data, which may not take, which probably not be 0.0 seconds, maybe 10 seconds, but it's still faster than the 280 seconds before that.
So we're going to get some usable access pattern we can do some analytics on. It's going to be about 10.1 seconds.
0.1 or maybe even more, 1 second, maybe up to 10 seconds. Okay. It'll probably take to get. It's not as, so in certain use cases, it's not as fast as it should be. So you'll probably get worse performance in an RDBMS, but it's still better performance than HDFS. So I'll still take the 10 seconds any day or the 280 seconds. Because no matter what you do in Hive, it always has to process all the data. There's no concept of storing the data unless you pre-compute your data or store your pre-compute sort of data somewhere, and then you only compute on top of that, which case you can probably get better performance. But in any rate, you still have to start the MapReduce job, right? So it has to start the JVM, start all the things required with the JVM, and then stop the JVM once it's done. That overhead itself takes a long time. Even though they've shortened it out, so in there they actually do JVM pooling, so you don't have to start and stop JVMs. They already have a bunch of JVMs which are available to reuse. So the jobs can just go and pull one of those JVMs and start processing within that, and then you queue it up when it's done. That's the whole thing with Days and Yarn. Good.
Does Phoenix have support for like UTFs?
I am not sure about that. I'll have to double check. I know, so when you talk about UTFs, you're talking about Java based or Python based? You're just in Java. Because UTFs is user defined functions. As I mentioned, co-processors is exactly that.
Okay, gotcha.
So, but when I thought you meant UTFs, you're talking about Java or Python. But if you're looking for UTFs, you just do co-processors. Right now it's all Java based. And starting 0.96, they all went to protobufs. So you can actually write protobufs for your co-processors. So the next thing I want to talk about is OpenTSDB 2.0. Stands for Open Time Series Database. OpenTSDB is built on top of HBase. So it's a distributed scalable time series database on top of HBase. What is time series? Data points for identity over time. It stores trillions of data points, never loses precision, scales using HBase. Good for system monitoring and measurement, servers and networks, sensor data, Internet of Things, SCADA, financial data, results of scientific experiments, etc. So some people who use OpenTSDB OVH, which is the third largest cloud hosting provider, to monitor everything from networking, temperature, voltage to resource utilization, etc. Yahoo uses it to monitor application performance and statistics. Arista Networking uses it for high performance networking. There are other users such as Pinterest, eBay, Box, etc. The last thing I want to mention is Cloudera. So, how many of you are familiar with Yarn? So Yarn is Hadoop 2.2 or the next generation of Hadoop. So Yarn basically is this framework that's built on top of HDFS that allows you to do multi-tenancy, running multiple applications on top of HDFS. Prior to Hadoop 2.2, Hadoop 1, the only thing you could run on top of Hadoop was MapReduce. And if you want to run HBase, what you typically did was you actually published, isolated memory for MapReduce and for HBase. So if you ever had like 48 gigs of RAM, you would in your configuration, you you would tell MapReduce to only use 24 gigs, and the HBase would be able to use the other 24 gigs. In Yarn, you don't need to do that. It allows it allows multiple applications to run simultaneously on top of it. So things like Hive, Pig, Flume, Spark, and other things can run on top of Yarn, on top of HDFS. It also allows you to get do access control. So let's say you have data scientists and you have administrators and developers. You can give different sets of users different access to the data by just saying that this particular class of users can have this access to the cluster. This particular class of users can have this set of access to the cluster. So one of the big things with HBase and with Yarn has this concept of resource manager, application master, node manager, but they are all short-living, which means they, when an application requests for resources, they put it they request a resource manager. They launch the application master, which lasts only for the lifetime of the application. The moment the application the process finishes running, it dies. HBase is a long-running application, does not die. It continuously keeps running. So one of the things was it wasn't able to work efficiently on top of Yarn. Cloudera is a project that was built to make HBase run efficiently on top of Yarn. So Yarn applications deploy existing distributed applications on Yarn, monitor them and make them larger or smaller as desired, even while the application is running. It's an incubated Apache project similar to Pace for HivePay. Applications can be stopped, frozen, and restarted. Can also be thawed later. Allows users to create and run multiple instances of applications, even with different application versions if needed. And it was also found that not just HBase required this kind of resource, but applications such as Accumulate and Storm. So multiple applications can run on top of Slide on top of Yarn. So I'm exactly on time, so that's what I have for today. Any questions?
Thank you.
Go ahead.
I had heard that HBase is better than Cassandra for time series data. Do you agree, and could you expand on that?
So I'm not very familiar with Cassandra, other than I know it's a ring-centric architecture, and HBase has this master slave architecture. So I can't speak too much to Cassandra, and I don't want to, say something against it. So what I do know is that HBase, the way HBase stores data on disk is timestamps. So every time you actually write, even when you do an update, the way it updates is actually timestamps it. So if you say, you're wearing black shirt today, tomorrow you're wearing blue, and tomorrow the day after you're wearing gray. By default, HBase always gives you the most recent version. So if you don't say all versions, it just give you the most recent version. The way it finds out this is timestamp. That's how it does the updates. And then you can actually tell it, give you all versions. By default, it's 3, so it'll give you the last 3 versions. So that's why, as I mentioned, OpenTSDB, which is the time series you're talking about, is built on top of HBase. When you talk about time series, that's what people actually use. OpenTSDB, which is built on top of it. Make sense?
Yes, thank you.
Does it have a way of flashing all timestamp data?
So what do you mean flashing all timestamp?
So if you don't care about the 10th last thing that...
So by default, it gives you 3 versions,
yeah.
And then 2 stones are remaining. So just as over time, it just overrides it. So if you want to do last 10, you have to change the configuration. So it's to last 10. One of the things that HBase does offer snapshotting. So if you know what snapshotting is, it actually does point in time snapshots of how your data looks. So a lot of customers ask for that. So if you, for some reason, let's say you change your data over a period of time and you want to see how your data looks 15 days ago, you can actually go back to a snapshot and see how the data looks. So this is in addition to the 3 versions. Again, it's all dependent on how much data you have on disk. The more space you have, you can do all these things. The less space you have, it eats up more and more space on disk. Yeah, go ahead. Yeah, you.
How does HBase handle a master failure with the hardware?
So right now it has automatic failure. So HBase has a concept of automatic failover. So whenever you do HBase, you actually specify 2 masters and Zookeeper. So the way it does is, right now it has Zookeeper. If you know what Zookeeper is, it's a quorum-based collection of servers. And when Zookeeper, the master's heartbeat into Zookeeper. If at some point, the master is not, or it takes too much time to heartbeat into Zookeeper. Zookeeper will then say, oh, masters down. So then they do the Paxos algorithm, which is the odd number of consensus servers to determine who the next server is. So Paxos algorithm based on that. You need to have odd number of people because it's majority wins. So majority have to vote. If you have even number of servers, they can't vote and say who's going to be the winner. So you have to have odd number and the Paxos algorithm will determine who the next master is, and then it'll then point and say, okay, the next master is this guy, and then everyone will go to that.
If we're doing statistical analysis using SAS or R, is Phoenix and HBase a good combination for that?
I am not so familiar with how you would do R on top of HBase. I mean, I'm sure if it has a SQL connector, you can probably say, tell R to call Phoenix as SQL and then use it. I haven't heard of anyone using R on top of Phoenix. I'm sure you could probably do it. I'm not so familiar. Maybe the data science guys are more. Can R directly call a SQL thing, or how does it? I don't know.
You can call some SQL databases directly from R, but I have no idea if HBase is one of them.
Yeah. So.
What are people doing then? If you want to run an analytics, are they using Hadoop?
For running analytics on top of me.
Yeah, you're saying there's MapReduce. Hadoop has MapReduce. Probably has some machine learning, some other time-driven libraries. Is that what they're doing?
For running analytics, you mean recommendations or just analytics?
Anything like that.
So there are a number of packages available on Hadoop, right? So Mahout is one. Spark ML is also being used. Also, Cloudera has open source now. It's open. They're still working. Oryx, which is based on Merix, so they're also one of the recommendations built on top of Hadoop. So there are a number of packages out there that people use putting recommendations at least. There's also this thing called Kiji, which is built on top of HBase, and they do real-time models. So you can actually build a real-time model, and you can replace the models in real time on top of HBase using Kiji.
Was that the talk last week? The proprietary solution?
No, it's all open source.
It's open source?
It's all open source. So Kiji is open source by VB-Data. So if you search for VB-Data Kiji, KIGI, you should be able to see it. It's open source. You can download and implement it.
What's the consistency granularity? Is it single row, multi-row, multi-table?
So consistency, good question. Consistency currently is at the row level. They are working to make it table level too, but right now it's at row level.
So if you're using a secondary table to simulate an index, you'd have to enter a record into both tables. There's a period in between that they're potentially out of.
Yeah, so the thing with HBase, it's not transaction. By no way, it doesn't. It's not asset based, not transaction oriented. So you can't ask of it to do those things right now. So I doubt it'll be able to asset just because it does not have all the features. As only consistency and partition tolerance, it doesn't have all the features. It won't be. Even though there's a company called Splice Machine that claims to asset on top of HBase. So they do real-time asset on top of it. I don't know if they are free or open source. Should check them out. But Splice, they recently raised $3 or $5 million for their solution. They claim to be asset on top of HBase, and they support transactions too. Any other questions? All right, that's it for today. So before I wrap up, let me call Aaron. So Aaron is from Factual. He's actually helping us host the event today. So Aaron, maybe you want, I usually do this at the beginning, I completely forgot. You want to just come and talk and let people know what Factual is?
Really, I just want to say that I'm glad everyone could make it tonight. I'm glad you could show up. We're really happy to have you. It's an honor to be able to host the Big Data meetup. So thanks a lot for coming tonight.
No, hopefully we get to see you in the next meetup as well. This September 10th meetup will be happening in Factual. So you guys should come down for that. Before we break for the day, has everyone got the raffle tickets? Oh, Aaron, do you have some people who have raffle tickets?
Sure.
So I would like to thank the folks at O'Reilly for this. They've contributed several books. Also, if you want a free ticket to Strata, you need to put your business card into that. I did that last week. This is the last week I'm going to do it before we pull up and send it off to Morality ticket. And we have several books today to hand out. So if you don't stay back, we leave, you're going to miss out on that.
On HBase.
But a lot of the small ones, I think I will just throw them. But those are like really like, I wouldn't even know I have one. Hopefully. And you know who is writing those books. It correlates with those people who are famous on Twitter. They I like celebrity. Like your girl. I mean, all of them are like okay people. I'm pretty sure they're like they're like because they're tweeting, they're like 100 times their short thing.
Oh, absolutely.
Okay, so you got books on HBase, Hive, Hadoop. What else do we have? Scoop, Hadoop operations. So quite a few books we have today to go. So Orion is being very generous in giving these books. So best let the best man win or best woman. Madam. Okay. So we're gonna start this. Has anyone got the raffle ticket? Alright, Aaron, since you're host.
No, I don't want to. You're responsible. To blame it on you.
Okay, so we're gonna do this for the Hadoop book. So I mean, it's third edition. Came out a couple of years ago, but still pretty good. So 713967. 967? Nobody?
Wow.
Okay, we're gonna do it.
And 968.
Recycling.
You have what next to me? 969.
713963. 963. I don't know, are you sure you got the right reference?
Book is getting lonely.
People have laps, maybe.
What are the odds it can happen again?
714279. Oh, hey. Alright, the next one we're going to do is on HBase. I think we have 2 copies of HBase. So we're going to get the host of the data science meetup to do it. Salat?
I hope it's not mine. No, but close.
713966.
966.
966? Okay. There you go.
Thank you.
Alright, for the next HBase book. Yeah, Ross.
Oh.
Pick someone. Hopefully it's not you.
Is 714? Oh, there you go.
714281.
Which one is it?
All right.
There you go.
Thanks.
Alright, so next one I'm going to do is Hive. Programming Hive. So who wants to take off? 714303.
Throw that in.
All right.
Alright, the next book we're going to do is Hadoop Operations. And let's go somewhere in the back.
Yeah.
714284.
That was easy.
Thank you.
Now we got the
Uh,
business model.
Okay, now you got the scoop book. I'm going to go around and see who wants to pick this one. Seven one four two eight seven. 287. Nobody?
Some of them go to
714293. So we got some t-shirts too out here.
You guys like mine?
Yeah.
Right?
Unfortunately, the sizes are something I'm not very. They are medium.
How about small?
Another medium. Another small. I'm just going to throw this. If you catch them, you will get them.
Yeah, catch up.
Just say.
You got to come up.
There you go.
Here, take it.
There you go.
I have a couple of pens too for Morali, just very good pens. Unless you want to laugh at them.
Don't stab people in the eye though.
Who wants a pen? Who's very desperate for it? Alrighty, grab one.
Awesome. Thank you.
Almost got him in the eye.
I don't know if I have anything else. There are some books on business models for the data economy. Anyone interested in these?
Those are not books.
Chapters.
Yeah, what would be so big to preview? It's like, what is up with? You would think it would be fit.
Anyone else wants it?
What?
I think that would be an important,
I don't know. The last
that would actually be more important than
If it's got
the
this barcode in it,
technical ones. But
this was printed in Bradenton, Pennsylvania.
How many pages?
This book is 20 pages.
I just read it
I have
on
a few books on practical machine learning innovations and
my
recommendation.
company.
This is by Ted Dunning. It's a pretty good author. So, I'm not sure. It's not the whole book, but it's a chapter. So pretty good.
The author is good.
I'm actually in the process of getting
The author is good.
You want to raffle that?
Given
Okay, let's raffle it.
alpha.
Alright, we're going to raffle these books off. It sounds like pretty interesting. There are two of them. So,
Work on our beta. A lot of development going on with the betas. Good stuff.
So they paid a lot of money. This was printed. It was say color stream. This was
practical machine learning innovations and recommendation.
You can write.
So,
Like this in
74272.
one day.
Oh.
272.
It's fucking ridiculous.
I have someone for
What was that?
It's rubbish.
714280.
280.
You pick one for you. 714292. 292?
Here.
Oh. Okay, we have one more book to give out. Yeah, since you're John, so give it back.
Try
Okay.
make your own.
Yeah, I'll try.
That'd be kind of interesting. Like it's
714277.
277.
So there we go.
There you go. Okay, that's it for today. Thanks for coming. We'll see you in September.
Show me the very printed in Bradenton, Pennsylvania.
Oh, cool. All right.
Cool.
That's awesome.
All right. Thank you.
You don't, it's not your algorithm that prints all these? Is it different depending?
No. So I wrote the composer code that takes the one that actually lays it out on the press. And on the last page, you have to so this is portion of the batch.
Meaning they laid out all the pages.
So we get a PDF of the document, but we print them on 27-inch wide webs. So we're printing out different pages because then they go.
Question for you. So,
right. So the entire
does
web
Phoenix
is page 1, next page 4, next page 2,
Yeah.
next page 6.
Science salary survey? From last year.
Yeah, sure. Pretty neat.
Let's see how I compare. So that's for these types of
Any hardware, software,
curious.
yeah, go interview, get offers, that's how you know your salary.
I definitely have to learn how it is.
Yeah.
Wait. Go back.
Did it also say in D3?
We bind them together, we trim it, we stick it in a box, and we ship it.
Yeah, Hadoop Tools D3. You know what D3 is?
Just like
It's JavaScript visualization library. What does that have to do with Hadoop?
Still have
Weird.
warehouse.
Oh yeah.
There's no way.
So say if I have a quiz.
There's no reason to have a warehouse.
to make $105 per hour.
Right.
Oh, this is hourly rate, or is this?
Giant stacks of pages.
I don't think it's EM.
We have vast arrays of
Hard to say.
massive
Yeah,
meters.
but then it would come out of
Exactly what happens is it's just in order, and we go. The imposer says this
It says salary.
imposed in 36,000 to this
Support
one.
for secondary index.
Shipping.
That's only one.
Yeah, there is a lot of stuff you can do without.
We ship for the entire industry.
You insert in the
Yeah,
table.
it's pretty neat.
It actually writes
I mean, without
Everybody's like,
hardware.
oh, the books are going away.
What do you currently
I thought ebooks were. I thought it
Yeah, what you do is
Yeah.
Yeah, it's available, but it's a
We experimented.
Yeah, it's destroying like
all the books that were raised in the warehouse.
stuff for you.
Nobody does that anymore.
Okay.
It doesn't in or not just the catalog.
That's the one I like.
Whisper. Whisper. Oh, okay.
Layout.
Is that wait? There's Whisper and then there's Secret. Is there
I
another?
mean, it depends on your math.
It's like are they related? These are no, not at all.
Secret kind of needs a little bit of
Oh, okay. Okay.
But
Yeah, they're related to
So
conceptually.
it uses
There's still some
yeah, Secret is like
I already think there's a lot of value in the permanency. You can distribute a book and still have really high reliability reads.
So there's no connection.
Like you can take a book, you can have
I think they're becoming more and more basic. So the one that was pretty good, kind of like
It's like posting a gist and not
was
or something like
the
that.
guy who started Cloudera.
He's right there.
He's the founder.
Okay.
So that was one of the first.
No. People love
The machine learning
Okay.
stuff that's very
like
yeah, this was a use.
That's the thing.
Okay. So you go on there, you might create a handle or something. That's how people know.
I think if you're just tangents, still the first principal
They still developing physical
Thanks a lot.
It's not unique, and you can change it. Oh, okay. It's not you're also different. That was the physics.
That's me, builder.
But it was a lot of
Not to destroy
kind of data. It was exponential data. Statistical analysis.
It's exciting whenever I'm somewhere.
So it's a small team,
Makes me happy.
We actually like.
Take a while. I was in Barbados, and the random bookstore in Barbados near the beach had one of our books. I was just like,
Well,
Engineering team.
Yeah, I remember. Yeah, you were the only one who discovered data science LA on the Twitter feed before we announced it.
Oh yeah, well.
So what is the two developers?
Yeah, well, Tony had sent me a link about it.
There's two
before,
DevOps
so,
guys.
I was gonna update.
How dare him? I told him 60.
Oh no!
It's okay.
What do you say about it?
No, he followed our Twitter feed before anyone else.
Oh, early.
I think one day before the launch.
And then for like data science
Cool.
stuff, we have Python.
Some monthly YouTube,
Administrator.
Our admins with them will be on Rails.
Oh, okay. Okay.
DevOps uses
Oh, really?
He's the data scientist in cornerstone.
Yeah, absolutely.
He's another blogger.
Yes, he's interested in writing a blog.
Part of why I was
So you're not
Although
using
he's
it.
Python there.
desire to build like other like CI stuff.
Yeah, I know.
You build your
Closure. How about closure? That's another level, right? It's functional at least. So we like it.
Uses YAML rather than humongous JSON files.
It's very difficult.
I spent like a year of my life reading. Basically, you know, like
So they have a hundred.
It's basically a program, right?
Yeah.
So
Salt stack you can
we also have a lot of other considerations
that has a bunch of built-in functions.
in our current databases.
Are you deploying to the cloud, or you have your own data center?
There's no way we
Every
could do
person,
that.
every company is
To have our own data center.
database.
Yeah, I did that last job, but we had like 4 people.
Yeah, there are get lessons.
Well, I guess, I don't know, the universal term DevOps is kind of used and abused.
So
So you might have DevOps people, but you also might have teams of administrators. You know,
We don't. We have
They
like
do everything. They do.
if
If someone has a problem, we don't necessarily want them.
Yeah. There's an actual problem and I'm working
everything from, not just DevOps, desktop support,
Yeah.
system administration.
You know how I
Oh man, working with someone like, hey, what's going on with my laptop? I'm like, I don't know.
And they're doing like
Oh, right.
Yeah.
So that's the
but even then,
He's so happy that he's got his
there's some considerations around.
Not little.
No, yeah, but he goes to Target and like buys stuff at Target, and that's like he's like this giant
Yeah,
Chinese
so,
bro.
but
And I'm
I've
like,
seen it.
there's so much world out there. He's like, well, I just love it.
Yeah, same here.
You can ask
So how do you?
I try.
I'm
an Eagle Rock, so it's a bit of a pain.
Where do you work at?
I have my own company.
Oh, cool.
Product development.
But actually, like,
Basically
you can
software.
actually say, is this particular thing secure or not secure? So what's secure?
Right now, I'm personally tasked with a startup. It's not doing outdoor advertising. Basically, they have, no, they're not using any of this stuff. There is a bit of Internet of Things type thing going on where they're creating their own cabinets with basically using computer vision to count people in cars and things like that. It's not that fast, but it'll be a while before we have big data. But I'm always curious about these things.
Alright, I'll see you gentlemen.
Yeah, so really slowly but surely moving. Unfortunately, I forgot about that.
Hey, I got you a job.
I was just curious. Have you heard of data client?
We met.
Yes, at the.
Are you coming still to the database?
It's stream processing. And the reason I ask is I'm having someone.
I just scheduled one
I think I
for
had
August.
Well, next month they're going to be at the OC job. What do you call it? The hike. It's hike for me. But I'm running the group, so
Was it supposed to be at a cornerstone?
But yeah, so I was just curious.
Yeah, it sounds, maybe you want to show you.
Yeah, I'll check.
He said he looked it.
Okay.
Right.
So yeah, because he's running the OC Big Data Group or whatever. So we had him.
Because I
Big Data Joe.
Big Data Joe.
Yeah. So he came and spoke to our group on Hadoop, and he was kind of talking about Storm.
August 26th?
He mentioned Storm and smart streaming or whatever. And he was
you have my email?
talking about limitations. And
if I don't, then
I said, well, you know, basically like Storm is,
send you a link.
it's set to handle the Twitter fire hose.
Have you not made
so
some art
it's
data
just
science
6,000 kilograms per second. I'm like, well, that sounds like lots.
Why would I depend on
You know, and he said
Lambda?
that's with Spark streaming. It's fine to fall down after 100.
I have a GPU.
So what is this? It's not really, but they
We
released
started this data science and before you had a look at the website.
Well, the scalability
So we
I see
have
when it goes
several
horizontal, it
projects.
starts
One
getting.
is so it's, everything is community.
What do you
So
call it?
since you are
This
data
report
scientists,
was
you're probably
created by some
interested.
Yahoo people.
So
Hadoop,
we have
you know, from
a
that
running
team, whatever, and it's
database
quote unquote
or
enterprise.
data science.
And they said that they're
That's
processing
one
Twitter fire
project.
hose
Another
on
one
a
is
single
blog
laptop,
posts
using a
by,
giga memory, computing top 10 hashtags in a rolling 5-minute window.
blog posts.
You know, just on one
Especially
node.
from companies.
And that's they've got a community edition. Community edition is limited to like 25.
Something
It's
like
based on memory.
we're looking even for
So it's
people
limited
who
to 25
contribute
gigs of
like
memory,
one
but they're
post a year.
like, since you can do that with
Yeah,
just
it's
a
not
laptop,
like a committee. Right.
It sounded a little
definitely
like
we
that
have to
scale out software in memory.
Right now we're in the process of
But there seems like they're adding a lot
setting
of
up
like,
our
functions to it.
Hadoop clusters.
So it sounded interesting because he was saying that.
But
What?
definitely, like
I don't
as it
know,
goes
it's,
further,
it's, you know, community edition is capped or whatever.
I mean, I've worked in other companies before.
What I was going to say
So it's not
is if you got a
source,
story
but
you want to
it
tell
sounded
about
like you
data
could
science
do
that you
so
did,
much processing
that you want to have showcased on data science, it doesn't have to be about your data. It doesn't.
And they were saying
It just
that,
has to be about
they were
data
talking
science.
about processing
And
over millions
if you're
of
interested
processes.
during the process,
Did
you
they
know,
have that doctor
you get an
who was
editor
doing
who
that
helps you
the other
edit
time
your
that has
Scale
that-
out.
editor that helps you
Yeah,
edit your work and
last week.
Yeah.
and all that.
And that was interesting, but that seems like that's all proprietary too.
Yeah, so it's
Yeah,
close.
And I didn't hear about
we
any
almost
community edition.
like professional.
So I honestly, if there wasn't a community edition of data
because
torrent,
his
I would
wife
talk
is an
about it.
editor.
You know,
That's my personal thing. Is
He's a
I like
professional,
source. I at
so-
least want to see. It's like another tool I like is Talent.
We have
Yeah.
an
Studio,
editor.
and at least
We have a
there's that's open
professional
source. There's
So,
you know the free version you can do it.
I work at a company called
That's why I see. But there's a moment where when it goes to the enterprise,
they're based
people
out of
get
Nashville,
like
Tennessee.
isolated. It says
Yeah,
now we're going to make money
we
because
printed this
we
book.
have a service level.
This
We
book
have
was
an
printed in our
agreement
Brainingsville
with our
facility.
customers.
Like,
So functions.
we barge all the
But
coal
yet,
and grain on the
there's that
Mississippi.
point in time where
We
you
ship
got
all of the beer
the
west
people
of the
are
Mississippi,
in the
like
community
that kind of stuff.
is working on.
Yeah, and I'm the guy on the West Coast. I
are
actually
just
quit my job,
versions
moved
of
out
it
to
to
the West
make
Coast
it
because I
how
started
it
living in
works.
the Deep
But when
South.
it goes into enterprise, it seems like it leaves a
And they just hire me back to just
different realm of
we don't care.
people
Enjoy
work. You
Santa
know, it's
Monica,
more,
it's
it
fine.
becomes it,
Yeah.
it becomes
How big
out
is
of
the,
the playing field. But yet,
What do you mean by
people are
this?
so
data science or security.
So I primarily work on the robotics side. I've just recently started moving into the data side. We have a pretty large BI group. We have a pretty good
Well, I
operational.
mean, you're talking about
right?
enterprise
So
software in
people
general.
who are already in
It's
statistical
typically
modeling
about
on
risk
fundamental
mitigation.
operation research
That's,
because
so that's